Calculus class, welcome to our calculus class. Today is determine end behavior using graph. Our problem is use the graph of fx to find the limit. The dashed line is on asymptote. Okay, before to make the graph here, let me remember some ideas for our class today. One is the limit. One idea, the limit line gx is what the values of gx approach as x increase without bound. Okay, this is this in this case this limit may or not exist. Okay, this is one concept belong to our class. So another great idea, the limit the limit g of x when x approach, in this case approach to negative infinity, is what the values of gx approach as x decreases without bound. Here the limit may or not exist. Okay, and then this is one idea. Another one, the limit, some concepts I write in some main points belong to this class. Before to make the graph and then solve the problem, the line y equals 8 is horizontal. Okay, it's horizontal asymptote. Asymptote of the graph of g of x, if only if at least one of the limits, at least one of the limits. So in this case is limit gx when x approach to negative infinity, or limit g of x when x approach to infinity, positive infinity. Yeah, that's it. So these main ideas is great to remember before to solve our problem. So now let me drop the graph right here. We have our problem here, the first problem. So let's Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 10. 3, 4, 5, 6, 7, 8, 9, 10. 10. 10. That's it. That's enough. I will mark 1, 2, 3, -4. Mark some points 1, 2, 3, 4 right here, and then let me write 4, 5, 6, 7, 8, and let me write 1, 1, 1 and 2, 3, 4, 5, 6, 6, 7, 8, 9, 10. Like that, something like that. Okay, I will drop but before the asymptote, the line, we're talking about use the graph of the Vx to find the limit, the dashed line as an asymptote. So the line is right here. Okay, let me make the picture about the line. This is the asymptote. All right, and then the graph is this is the point, the graph right here. We have this is number 1 here, and then the graph is all the way up right here, all the way right here. This is 8 right here. So something like this. Then the graph is crossed right here, and then also it's another point right here. A little curve. Okay, and also right here. Just like that. You see the graph, the picture right here, right? This is our problem then. So how solve this problem? Here, find the limit. Here is find the limit of the problem. Look at this. Find the limit. I'm going to show you how to determine the behavior using graph. Okay. Find the limit. Here, the limit of f of x, all right, when x approach to infinity. Okay, it's positive. Okay, this is our look at this. Looks, what happens to the graph? What is happening to our graph of f of x? This is the graph f of x. F of x. Right? As x increase without bound. Okay? So the graph of f of x approach, in this case, approach the horizontal asymptote. Let me write it right here. The main point, the graph here, the graph of f of x, this one, this graph, approach the horizontal. So the horizontal asymptote. What is the horizontal asymptote? It's y equals what? Y equals 1, right? As x increase without bounds. All right. So our conclusion here. So in this case, so limit of f of x, right, when x approach to infinity is equals what? Is equals 1. All right. This is the solution. So use the graph, the f of x, to find the limit. The dashed line is an asymptotic, or that means this line, okay, is asymptotic, right? This is the solution of our problem. Let me show you another problem. Let's see another problem with a different graph, okay, with a different graph. So let's let me make a picture of the graph right here. This is really my graph, like this, okay. It's another problem, same thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6. 6. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Negative 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Negative 10. Negative 10. I'm gonna put some point here. 1, 2, 3, negative 4. Let's write right here 1, 2, 3, 5. Some points. Okay. Also so this is 1, 2, 3, 4, 5, 6, 7, 8. Negative 8. So negative 6. Okay, those points. That's good. So now let me write that in this case the line, the asymptote, the line, the dashed line is crossing in this point. The line is right here, exactly in number 8, right? All right. So let me make the graph. So the graph is 1, 2, 3 right here, 3, so 1 point. So and a half, 2.5 points, and then just move it to this direction to the 6 or so right here, and then the other point is 6 and negative 4. So like this. So the graph is crossing this point, number 2, and then here at number 2. So the graph is moving like this. This is my graph. All right, this is my graph. Okay, so I want to show how this topic work. Okay, look at our graph. So now here we have to find here find the limit of f of x, right? In this case, when x approach to negative infinity, right? See the formula here? So what happens to the graph? What happens to this graph of f of x? F of x. As x decrease, in this case, and the x is decreasing. Decrease without one. Okay. So the graph of f of x here approach the horizontal, approach to the horizontal asymptotic, horizontal line. Okay, it's asymptotic. So let me write here the graph as a conclusion. The graph of f of x approach the horizontal. Okay, the horizontal line in this case called asymptote. Okay, in which point, where is the asymptote or the horizontal line is in this y equals negative 8 right here, right? Negative 8. As x decrease, in this case, as x decrease, so as x decrease without bound. So our conclusion here, so limit f of x when x approach to negative infinity is equals negative 8. See? You see how fine they determine the end behavior using graph? It's very simple topic for calculus, very easy, but it's very important to see the picture, the graph. It's very simple. Just try to translate it or find the concept about how determine. So it says just check the line, where is the horizontal line or the asymptotic, and then this point is very important. And then when the limit is when x approach to positive infinity or negative infinity. So in this case it's negative infinity, okay? You discover the power of the mathematics, unleash your infinity potential.